Geography 300, a geographical data analysis video series for WVU. This week, this set of videos is our third out of 3 topics on regression. Now, what we have seen thus far is our regular linear regression, and we have seen one way of bringing space in to have a spatial lag or a spatial error to account for interdependence among either something that is missing or about within the dependent variable itself, breaking the assumption that all of the residuals or errors are independent of each other. This week, building upon that, we'll first look at multivariate regression, which in a sense builds off of the idea of, well, okay, if there's a missing variable, why not just include it? And the other approach that we'll see this set of videos starting a little bit later is what I had earlier as the third approach to solving or addressing some kind of spatial interaction within our regression called geographically weighted regression. But first, multivariate regression. Conceptually, at least, and if we put in some of the math, it's a little, solving it is much more challenging. But we have software to do that. The interpretation is fairly straightforward. Right now we're not worrying about space. So we're building again off of that basic ordinary least squares linear regression. So I'll put that up here. So that's in space, of course. We'll see that filled in shortly. So we have our regular linear regression. Our dependent variable, the coefficient, or what's the constant in some of the software. So, or the intercept, the coefficient, and our independent variable, and our error or residual. In this linear form, there's nothing that says we have to stop at just one independent variable. So I can say beta 1 x1. I can put in as many as I want. I left space for 3. So right now, in terms of the general approach here, we'll get into some of the interpretation details in the next video. So the idea here, we still have one dependent variable, but we can have many independent variables. How we interpret the residual has not changed. How we interpret each individual coefficient is the effect for that particular variable. The other difference is with the intercept. It's when every single independent variable is equal to 0. So the bottom line here, if we thought it was kind of unlikely that we would have a situation where our one independent variable was equal to 0 for including the intercept in our regression interpretation and discussion, for the bivariate setup, it's even less likely to be that relevant in the multivariate setup. Because, again, how often are you going to find a place, a county, a weather station, any observation, for which every single independent variable is equal to 0. There are, I'm sure, some situations where that is the case. It doesn't happen that much within geography or within spatial analysis. So this is the introduction here to multivariate regression. One dependent variable, but we now have many, or one dependent, many independent variables. And we'll see, and we can actually put in the spatial error term. We can put in a spatial lag term to this. You may have noticed in the software as you're going through the spatial regression lab that it will let you put in more than one independent variable. It's doing exactly this. Looking at things that would be in the output table for that, we will see that in the next video. So, as always, if you have questions, feel free to ask in the Zoom class or by email. Have a good one.